Deep beneath the breathtaking landscape of Yellowstone National Park lies a ticking time bomb, one of the most awe-inspiring natural wonders in the world. Scientists and the public alike are both fascinated and fearful of the sleeping giant. The giant is about to wake up again. Let's see how things shape when it does. The Yellowstone Caldera is a massive volcanic feature measuring 55 kilometers by 72 kilometers and contains a magma chamber estimated to be 88 kilometers long and 29 kilometers wide. The caldera was formed by volcanic eruptions over the past 2 million years. The most recent explosion occurred about 640,000 years ago, one of the most significant volcanic eruptions in the planet's history. It is classified as a supervolcano because of its size and the potential magnitude of its eruptions. A supervolcanic eruption is an eruption that ejects more than 1,000 cubic kilometers of volcanic material. The Yellowstone Caldera has had 3 supervolcanic outbreaks, the most recent being 640,000 years ago. The ash and volcanic debris from these eruptions covered much of the western United States, and the impact on the climate and environment was felt globally. Today, scientists monitor the Yellowstone Caldera closely to detect any signs of volcanic activity. The caldera has experienced significant uplift over the past few decades, and the ground above the magma chamber has risen by as much as 70 centimeters in some areas. This uplift is a sign that magma is moving into the room and is a cause for concern for scientists. If the Yellowstone Caldera were to erupt again, the impact on the environment and human civilization would be catastrophic. The eruption could eject ash and volcanic debris into the atmosphere, blocking the sun and causing a drop in global temperatures. It could also trigger earthquakes, landslides, and tsunamis that devastate nearby communities. As explained in the previous chapter, the presence of Yellowstone Caldera and its imminent eruption is due to helium gas. This discovery by scientists is named ancient helium gas. Ancient helium gas is one of the many fascinating elements in the Yellowstone Caldera. Helium, the second lightest element in the periodic table, is a colorless, odorless, and non-toxic gas with critical industrial and scientific applications. However, the helium found within the Yellowstone Caldera is unique in its origins and properties. The helium found within the Yellowstone Caldera is thought to be millions of years old and is a remnant of the volcanic activity that created the caldera in the first place. As magma rises to the surface during volcanic eruptions, it brings various gases, including helium. While most of these gases escape into the atmosphere during the explosion, some become trapped within the solidified volcanic rock as it cools. Over time, the trapped gases become chemically bound to the minerals in the rock and become part of the geological record of the area. In the case of Yellowstone, the ancient helium found within the caldera has been preserved for millions of years, locked away in the rocks deep below the surface. Today, scientists study the ancient helium gas within the Yellowstone Caldera to learn more about the area's geological history and to better understand the processes that lead to the formation of volcanic calderas. By analyzing the isotopic composition of the helium gas, scientists can gain insights into the age of the rocks and the conditions under which they were formed. While the ancient helium gas within the Yellowstone Caldera may not have any immediate practical applications, its existence is a testament to the remarkable natural processes that have shaped our planet over millions of years. As we continue to explore and learn from the geological wonders of Yellowstone and other natural areas, we gain a deeper appreciation for the incredible complexity and diversity of the world around us. Despite its immense size and potential for catastrophic eruption, much about the inner workings of the caldera remains a mystery. However, by combining geophysical and geochemical studies, researchers have begun a better understanding how the caldera operates. At the heart of the Yellowstone Caldera is a large magma chamber, which is responsible for much of the geothermal activity in the area. The magma chamber is estimated to be about 50 kilometers wide and 12 kilometers deep, and it is thought to contain a mixture of molten rock, gases, and other volcanic materials. As magma rises from the mantle and accumulates in the chamber, it can generate pressure that can trigger volcanic activity. One of the key challenges in studying the Yellowstone Caldera is that much of the magma chamber and surrounding rock is inaccessible. However, scientists have developed several techniques to indirectly study the inner workings of the caldera. Researchers have discovered through these studies that the Yellowstone Caldera is incredibly dynamic. Magma constantly moves through the subsurface, and minor earthquakes and tremors are expected as the rock adjusts to the changing pressures and temperatures. In addition, the caldera undergoes periodic cycles of uplift and subsidence, which can be caused by changes in the volume of the magma chamber or other factors. While the chances of a catastrophic eruption at Yellowstone Caldera soon are relatively low, but the potential impacts of such an event are enormous. In the past, explosions at the caldera have released vast amounts of ash and volcanic material into the atmosphere, creating massive volcanic depressions and other features. One of the biggest concerns surrounding an eruption at Yellowstone Caldera is the potential impact on human populations and infrastructure. The area surrounding the caldera is home to several large cities, including Salt Lake City and Denver, and an eruption could release ash and other materials that could cause widespread damage to buildings and infrastructure and pose a severe health hazard to humans and animals. An eruption at Yellowstone Caldera could have long-term consequences for global climate and ecology. The ash and gases released by the blast could block out sunlight and cause global cooling, which could significantly affect agriculture and other human activities. In addition, releasing sulfur dioxide and other gases could contribute to acid rain and other environmental problems. An eruption could cause significant damage to the surrounding area, including destroying buildings, roads, and other infrastructure. An outbreak could release large amounts of volcanic ash into the atmosphere, spreading over a wide area and potentially reaching other countries. This could significantly impact air travel and cause health problems for people who breathe in the ash. The release of large amounts of volcanic ash and other gases into the atmosphere could also significantly impact the global climate. This could result in decreased temperatures and altered weather patterns. An eruption could also trigger a more enormous tsunami, which could cause significant damage to the coastal areas. This eruption could have a long-term effect on the environment and the ecosystem, potentially causing changes to the landscape, wildlife, and water sources. Despite these potential risks, it is essential to note that the likelihood of a catastrophic eruption at Yellowstone Caldera soon is relatively low. Scientists are closely monitoring the caldera and developing strategies for mitigating the potential impacts of an explosion, should one occur. By continuing to study the inner workings of this fascinating and complex geological feature, they hope to better understand how it operates and how we can best prepare for the potential risks it poses. While much about the inner workings of the Yellowstone Caldera remains unknown, significant progress has been made in recent years in understanding its structure and behavior. Through a combination of geophysical and geochemical studies, researchers have gained a better understanding of the role of the magma chamber and the factors that can trigger volcanic activity. One of the most significant challenges associated with the Yellowstone Caldera is the potential for a catastrophic eruption. With ongoing seismic activity and the potential for a catastrophic eruption, the Yellowstone Caldera has remained relatively quiet in recent years. However, the threat of a future outbreak continues to loom, with the potential to cause widespread devastation and impact global climate patterns. Efforts to monitor and study the caldera are ongoing, with scientists working to better understand the complex geologic processes. Ultimately, the fate of the Yellowstone Caldera remains uncertain, serving as a reminder of the power and unpredictability of the natural world. Although the likelihood of such an event soon is relatively low, the potential impacts on human populations and the environment are enormous. Scientists are working to develop strategies for mitigating the potential risks of an eruption, including monitoring the caldera for signs of increased activity and developing evacuation plans for the surrounding region. Considering the potential risks, the Yellowstone Caldera remains a vital scientific resource and a popular tourist destination. Its unique features, including the iconic Old Faithful geyser, draw millions of visitors to the region each year, and it continues to be a focus of scientific research and discovery. Remember to subscribe to the channel to see more mysterious videos in the future. The Yellowstone Caldera remains a captivating wonder of geology, providing a glimpse into the Earth's dynamic and ever-changing nature. Click on the video links on your screens to explore more mysteries of the Yellowstone.